So today we are going to see a shortcut, right, in the stereoisomerism of cyclohexane. So the topic we are going to see today is, if I have stereoisomers in the cyclohexane planar structure, right, how am I going to incorporate that into the chair form, right? Okay. So first we'll try to understand how do we represent geometrical isomers or stereoisomers in cyclohexane compounds, right? So first we'll take the planar structure, then we'll try to incorporate it in the chair structure, right? So let me take a very small example, right? So I am going to take the example of cis 1,2 dimethyl cyclohexane, right? So you are going to see that there are a lot of information here. There is going to be two methyl groups in 1 and 2 positions, and both these methyl groups must be cis to each other, right? So how do we draw it? We'll draw it to the planar structure of cyclohexane. This is how it looks, right? So let me put the positions 1 and 2 as any two adjacent carbon atoms, 1 and 2 carbon atoms, right? So now you have to understand that there are going to be two bonds for each of these carbon atoms, and it is going to look such like this. So I am going to have one bond pointing away, right? And for this also one bond pointing away, right? And there are going to be one more bond each where the bond is pointing towards you. So the wedge. So here also the bond is pointing towards you. So there are going to be two bonds, right? And one of the bond you are going to point away, the other bond is going to point towards you, right? Now, if it is going to be cis, if both the methyl groups are cis to each other, you have to make sure that either both of them is pointing away or both of them are pointing towards you. So what can be the possibilities? If I put the first methyl group pointing away like this, I have to put the second methyl group and the second carbon also to be pointing away. This is what is cis 1,2 dimethyl cyclohexane. Or if you want to put it in the wedge position, that is pointing towards you, the next one also should be in the wedge position, that is pointing towards you, right? Okay. Now we'll try to see how trans looks. Okay. So we are going to take the same example, that is 1,2 dimethyl cyclohexane, but the only difference is this time I am going to take trans in this, right? So if I take trans, the only thing which is going to differ is that, so I told you in case of cis, both of them should either point away or both of them should either point towards you. If it is going to be trans, if one of them is pointing towards you, the other one should be pointing away from you. So or vice versa. So now I'll just directly go for this. So if in this case first carbon atom I have CH3 to be in pointing away position, for the next one the CH3 should be pointing towards you. That is here, right? So trans, you can understand one thing pointing away and one thing pointing towards you. That is if it 1,2 dimethyl trans 1,2 dimethyl cyclohexane. Okay. So now we'll go to the topic of today, how we are going to incorporate the cis and trans models into chair forms, right? Okay. So we'll try to do that. Right. Fine. So let me take the first case again, cis 1,2 dimethyl cyclohexane, right? So for our reference, we will try to draw the planar structure here again. CH3, both pointing away or both pointing towards you, up to you. Okay. Now let me draw the cyclohexane chair first. Okay, so this is how roughly it looks, right? So here I am going to have axial and equatorial bonds. So now a lot of people will have confusion to put where to put the axial bonds, where to put the equatorial bonds. Now for that also I'll give you a shortcut. So assume that this is the headrest of the chair and this is the footrest of the chair. So if it is headrest, assume that the axial bond is going to point up, right? And if it is footrest, the axial bond is going to point down, right? And the next thing you'll understand is you are going to put the axial bonds pointing up and pointing down alternatively. That means if the first carbon atom has the axial bond pointing up, the second carbon atom will have the axial bond pointing down, and the next carbon atom is going to have the axial bond pointing up. The next one has pointing down, and the next one has pointing up, next one pointing down, next one pointing up. Right? Now when I go to the equatorial bonds, whatever you did for the axial bonds, do the opposite. That means if the axial bond is pointing up, put the equatorial bond pointing down. So let me go on with it. So axial bond pointing up, so equatorial bond pointing down, axial bond pointing down, equatorial bond pointing up, axial bond pointing up, equatorial bond pointing down, axial bond pointing down, equatorial bond pointing up, axial bond pointing up, equatorial bond pointing down, axial bond pointing down, equatorial bond pointing up. So hope you understood how do we fill the axial and equatorial bonds, right? So now the question, you can again take any two carbon atoms as first and second position. Okay, so now we are going to incorporate cis 1, 2 dimethyl cyclohexane. This is how it looks in planar structure, and we are going to put this here. Okay, now what I need to understand is when it comes to chair forms, it is not at all about whether it's axial or equatorial. It is not about that. It is about whether that particular bond is pointing up or pointing down. Again I repeat, it is not about axial and equatorial. It is about whether the bond is pointing up or down, right? So please understand, if I take this as the first carbon atom and I put a methyl group, I again have the question, where should I put the methyl group, either in axial or equatorial in the first way? It's up to you. Now the question will come, the choice you have to make, the choice is must when you go for the more stable position. So that we'll see in upcoming videos. So for today, you can put it anywhere, right? So let me put it in the axial position, the axial position which is pointing up in the first carbon atom, right? Now when I go for the second carbon atom, right, what I need to understand is, since it is cis, right, in the first carbon atom the methyl group is pointing up, the second carbon atom also the methyl group should point up. That is what you have to understand. Up, up, down, down. That is in the case of cis, right? So now the axial bond is pointing up. In the second carbon atom also I have to put the methyl group in the pointing up position, and that in this case is equatorial. Hope you understood. Up CH3, up CH3, because it is cis, right? So now if I have trans, what will happen? If one of the CH3 is pointing up, the next CH3 is going to point down, and that's what is trans. So again and again I repeat, it is not at all about equatorial and axial. It is about whether the bond is pointing up or down, right? So I think if you try to make the trans of this, you will be able to get a better picture. So same thing we'll do for trans. So I am going to take trans 1, 2 dimethyl cyclohexane. So this will change. It is going to look like this, a wedge with a CH3, right? So now I'll remove both these CH3s from here. Okay, now so again, first carbon atom is this. I can either put in axial or equatorial. So let me put it in axial again, which is pointing up, right? So now it is trans. Please understand that if the one of the bond is pointing up, right, the next second carbon atom methyl group should be pointing down. So obviously in this case I am going to have the methyl group here. You can see that first methyl group pointing up, second methyl group pointing down. This is what happens in terms of trans. So let's just consolidate. When I have cis, both bonds up or down, and if it is going to be trans, one up and the other down. It's very, very simple. So I hope you got a very beautiful shortcut to convert the planar structure into the chair structure. Thank you so much.